Hello everyone, this is M.Nouman and today we are going to work on GNU Radio Companion. So let's get started. And here we are, this is GNU Radio Companion, and today I want to talk to you a little bit about the GNU Radio Companion. It's kind of missed word because it's got the word radio in it, and granted usually when you are using this you want to do some sort of software defined radio project, but it's really more like the new signal processing companion. It will be a more accurate way to describe this software. In fact, you don't have to do radio things with it. You can just process general signals, some of which happen to come from a software defined radio. The first thing I want to do is just to sort of introduce the new radio companion and give you some things that you could try even without any specialized hardware, just so you can get familiar with the entire system on Python. But unless you do something exotic, you don't really need to know anything about Python. To get things to work, it does help if you know a little bit about how to construct certain syntax and formulas and things in Python. But frankly, it's about the same as C or C++, so it's a good bet you know it anyway, as pretty straightforward. This program to use, you can see it's very simple. This program that you are going to use is very simple looking. There is a window and a couple of blocks. That was already here when I opened this. As you see that when I launched, it was already there. So I will talk about that here in a second. And over on the right, bunch of interesting looking palette entries like audio and digital television, and here is the error coding and filters and for your analysis. So it's great fun to look at those and wonder what some of them are there is help and documentation. So we are going to use a few common blocks. We don't cover every single one of these blocks because if you realize these all grow up into even more blocks, right? So that's really just top level organization. So there's a lot and a lot of choices. So for right now we are going to fairly simple example. I'm going to give you a fairly simple example. So let's look at these blocks that are already here. One is the option block, and I'm going to double click on it, and this is going to where you do most of the work. In these properties dialogs, you can see it's called top block. There's a title. So there's a title and author. I'm not going to bother this one. Filing all that in, there's a window sign and there's some generate options. We are going to generate some graphical user interface elements, and as you can see, this one is generate options graphical user interface, and you know this is a cross-platform program, so you can use the WX or the WX widgets, but I think is that what they are called now, the WX GUI, and that's probably a good choice for Windows. It does work under Linux, or you can use Qt, which is obvious choice under Linux. In fact, works under Windows, so this is really kind of your choice. You can tell that you don't want any GUI at all. I'm on Linux right now. In fact, I'm on Kali Linux XFCE, so which uses the Qt. So I'm going to tell it I want the Qt GUI. Alright, so so that's really important, because when you go over here and start picking user interface elements, which are just some of those blocks, they'll give you the choice of whether you want Qt or WX. Good news is it's pretty much the same items available more or less for both systems, so it almost doesn't matter. It's just whichever your preference is or whatever is installed on your system. Obviously I'm going to click OK there. So now And here we, on the other side, we have a variable, and we all know that what is variable, so it's not very exciting. It's just some name and some under and some number, and that happens to be our simple rate. It's set automatically to 32,000. That has to match your hardware, this one. So I'm going to change mine to 48,000, and there's really nothing magic about this. So I'm going to change this to a 48,000, and it's just a variable, except most of these blocks will automatically use that number as. So I'm going to click OK as their sample rate, and I will show you what I mean, but that here in a second. So let's try something just really simple. I'm going to go to the waveform and generates item down here, and there's a couple of things here, by the way. If you wanted to not to have exactly where those are, if you come in here and press Ctrl F, you will get a little search box. Alright, so if I come here and if I click X, so I can search whatever I want. So if you want to define with what you want, you can just use the search box. So you know that it will kind of narrow that is down. In my case, I just happen to know what I wanted was under waveform generators, and I want the signal source. So under waveform generator, and I want the signal source like this. So I'm going to drag that just like I did here, and there's a couple of things that you notice, that this signal source is written in red, and that means there's something wrong here. If everything was okay, it would be black. Well, what's wrong is there nothing coming out of this block. The other thing to notice is there's a blue little nub here. That's the connection point, and that blue color tells me the data type, and in this case I just happen to know the data type is a complex type. But you will see there's other data types, and complex doesn't in this case mean complicated. I mean, complex number is a number with a real and imaginary part, and you can see it says the sample rates 48,000. Here you can see, as we have said here, the value of 48,000. So both have a conflict. The waveforms of cosine frequency, the amplitude, the offset, well, that's not really 48,000. Alright. What it is, it's that sample rate. So let me show you how I know that. If I bring up the properties again, and yeah, here we are. As you can see, this one is cosine. I double click on it, and the sample rate is set to sample rate here, and you will notice that's the same as the idea, that variable. So if I had changed this to 44.1 kilohertz, then that would have changed all the blocks. So out here on this diagram, in this case just one, but that's because what's the only one we have, it would change it to the right sample rate. Now if I wanted to specific sample rate for this block that wasn't that sample rate, I could hard code it here. Or I could pick it up from another variable, or you will see this in a little bit. You could pick it up from a GUI element, so you could have a slider or drop down box, those this one, those kind of things. So in this particular case we have got a cosine waveform. I think I would prefer a sine, but it doesn't really matter. Alright, and you see you have got other options like squares, triangles, sawtooth, etc. And you'll notice that's really a number. So if you look in here, put the mouse float, it will say that the sine this value is 101, type is integer, and key is waveform. Okay, so but like the cosine was 102 and now it is value 102, and if I select the square it will be value 103, and key is waveform and type is integer. So I'm going to go with sine. So those names are just handy, but the numbers are what's really important. And remember that because we are going to take advantage of that later, and let's just leave it at 1000 Hertz, this one, or 1 kilohertz, and the amplitudes. Okay, that's fine. And you can see I mentioned that the red title here said there was a problem, and that problem is right here. Okay, now I'm going to click OK. Here the port is not connected. The signal source is going to generate stuff as far as it can with a 48 kilo sample rate, and on my computer that's a lot of operations per second. It will make the computer kind of sluggish. So I'm going to go to the miscellaneous here, and I'm going to pull out a throttle. Let's search for miscellaneous. Here we are. Now I'm going to search for throttle. Yeah, this one. So I will put this one here and this one here. This is throttle block, and that throttle block will just say, look, I don't care if you can do this more often, I only need it 48,000 times a second. So that's going to be our first connection. Doesn't matter which of these knobs I click. I can click this one first, then just like this, and as you can see it makes a connection. I could have done it backwards, but it doesn't matter, that the colors are the same, and again that's a complex data type. Alright, and so you can select everything and drag it around. It's just kind of a typical GUI sort of thing. The next thing I want to do is I want to go to the instrumentation, and here we go. You have got your choice of QT and WX. If you pick the wrong one, you have got the option set for WX, and you can pick QT block or vice versa. You will get a cryptic error message. So let's close this. Now I'm going to search for instrumentations. Yep, here we are. So this is instrumentation, and from here I'm going to select QT. So these are the blocks. If you select the wrong one, you will definitely get a cryptic error message, and you'll have to figure out why that was. So just remember what you picked. It's QT in our case, and I am going to take a QT, let's say a frequency, this one, and frequency sync, and bring it over here. The actual QT GUI sync is really clever, so I'm going to drag and drop it here, and it's got a lot of tabs where you can pick, like an oscilloscope view. If I just open this, yeah, constellation syncs, etc. and a lot of different things. You will notice if you let your mouse flat over, it does give you some description like this. Most of these blocks there, sometimes they are really hard to read from how they are formatted, but it's better than nothing. So you can see both those blocks have a problem because they got picked. Alright, picked up the sample rate. Well, the reason they are both in red is because they are not connected. So I will click here, and then you will notice I did it backwards. So okay, so I'm going to click here, and that's fine. Now everything's black, so that's good, and we could really just go ahead and run. That will bring up the frequency. Synchronize properties. So let's click here, double click, and it brings the properties. First, you can see it's going to do a fast Fourier. So complex error, it's going to do 1024. This one, it's 1024 points, and there's a window type. If you're really familiar with FFTS, that's the window. So the window function that gets the input, yeah, so as you can see the properties, it's the type is anom and key is win type. So that's the window function that gets the input data from at the edges. From at the edges, I can change the center frequency. I can tell it if I want to get grid. So let's do that. So I'm going to go here and set the grid to yes and auto scale to yes also. So I can tell it auto scaling is done, whether or not I want averaging, update, period, all these things. There's also a GUI hint. I'm going to come back and tell you more about that in a bit, but just keep that in mind that there's this GUI hint that's going to help this one. So let me arrange things on the screen right now. I'm going to leave it blank. So I'm going to say okay, and now I'm going to save it. Going to save here, and I'm going to name it as test, and click set it on the desktop and click save. Alright, and then we are going to run the application. So as you can see, there is a play button here. You might expect that it will execute, and it does. If I click here, and as you can see, when you run it for the first time, you will definitely get an error, so just simply ignore it. And let me resize that a bit. So it's now better on the screen. So it's it's moving because we have set auto scale to yes, so that's kind of a large. You can scale it back up by doing this. So here you can see it's getting changed. So the noise at the bottom there's our 1K. More or less. If you blow that, you could get good enough resolution to really it's 1K, and then it kind of rolls out, and you can right click to reset scaling. Alright, like I go here, and now I'm going to click on right click and reset the scale. You can see the auto scaling is kind of making it jittery. You could turn that off. You can look at the minimum and maximum and hold, which for this would be pretty boring because it's always basically the same. So pretty interesting. Just a couple of blocks drawn on the screen, just like we did here. Just a couple of blocks on the screen, and the result is here. So I've got the FFT of the 1 kilohertz. That's a little bit boring because you know it's a sine wave of 1 kilohertz and it makes one spot there. So let's try to make it more interesting. So if you going to close that pop-up, what I want to do is I want to be able to vary the frequency of the signal source. If you look, there's a GUI widgets folder here under this. So this was just a little ROM demonstration for the graphical user interface, or GNU radio. So I hope you understand this video. Hope to see you in the next video. Bye.